We have completed our process and we've transferred our batch over to our holding tank. We're going to wait overnight, like we said, and let the glycerin settle to the bottom and let the fuel come to the top so that we have a good two-phase separation. I want to talk to you about records because records are very important. You have to keep a record on your batches. Every batch can differ in the amount of time you cook it, the heat that's used, the methanol that's used, the catalyst that's used, to the waste vegetable oil that you use to put into your batch. So keeping records is very, very important so that you can keep up with your process and say, was that a good batch? Was it a bad batch? Did I not cook it long enough? Did I cook it too long? Can I cut down on something to save some money in my process? Or can I do something to make my process better? So we're going to keep records. This is an example of kind of the records that it's a very simple record keeping system we do here to do our batches. You always want to write the date. You want to know what date you made your batch. Today is the 15th. We made our batch today. We used 30 gallons of waste vegetable oil, 7 gallons of methanol, and we calculated through our titration calculation that we needed 2.5 pounds of sodium hydroxide, and our oil titrated at 5. Okay? Now, I would like to see that titration to be 2 or 3. That's a really good waste vegetable oil that you collected from a restaurant. However, this one titrated at 5. It's a usable oil. I can make fuel out of that. It costs me a little more money to do that. And I don't get as good a conversion ratio as I would if the titration was a bit lower, because remember, the higher the titration, the less fatty acids you have attached to the glycerin backbone, and therefore the less fuel you're going to make in the end product. So 5 is doable. When you get up to titrations of say 7 or 8, you might as well not even use that oil because it's going to cost you too much money to make it a fuel product, and your fuel product is not going to be very efficient on your end. In other words, if this titration was 2 or 3, if I put 30 gallons of oil into my processor, I'm going to get 30 gallons of fuel out. However, when I get to 4s and 5s and 6s, I don't necessarily get a 1-to-1 ratio. I may have 30 gallons of oil going into my batch, and I may only get 25 gallons of fuel coming out of my batch. So that's the difference in titration. The lower the titration, the better the ratio from waste vegetable oil to final product produced. All right? We said that heating and mixing was very important, time-wise, temperature-wise. We stayed at 125 degrees Fahrenheit throughout our 4-hour mix time. We started at 1 p.m. and we stopped at 5 p.m. Okay? Now at some time within this frame, depending on the weather outside, if it's a summer day, you may not need to cook for 4 hours. If the temperature is a bit colder outside, you might need to cook for 4 hours. That's something you have to decide. If your oil titrated at 2, then maybe you can cut down on your cook and mix time here. You can never really cut down on your temperature time. It really needs to be 125 or higher to 130. But you can kind of play with this mix time depending on how good or bad your beginning waste oil is, okay? Now, in the morning when we come out and we let our product sit overnight and our glycerin sink to the bottom because it's more viscous, we want to write down how many gallons of glycerin we recovered from our settlement. And a good rule of thumb here is 20%. So if I have 30 gallons of waste oil going in, I put 7 gallons of methanol in, I better get 7 gallons of glycerin out, okay? Now this is going to fluctuate, again, with this titration amount. The higher the titration amount, you may get a little more than 20% glycerin that comes out of the end product as a byproduct. If this is 2 and 3, then that should be right at 7 gallons of glycerin coming out. So titration is very, very important. The next thing we're going to do tomorrow after we drain our glycerin is we're going to test our fuel to see if we have to reprocess. Did our transesterification reaction complete itself, or do we need to do the reaction again? And we do this by what we call a 27-3 test. Now the 27-3 test is a very crude test, but it's a pretty accurate test to let you know whether or not your batch fuel is going to meet ASTM standards and it's safe to put into your tractor or your truck. So let's just kind of go over the 27-3 test while we're talking about it here. like I said, it's a crude test to indicate whether or not your fuel product that you made is possibly going to pass the ASTM standard, okay? So it's a test to see how complete the reaction was. So in the morning, you'll come in and you'll take 27 mils of your methanol, your clean methanol, unused methanol. And then after you've drained your glycerin, you'll get 3 mils of your fuel in your batch that you made that day. You'll put it together, shake it up, and let it settle for about 5 minutes, okay? So what happens, if it passes, you won't see the biodiesel dissolves in the methanol, and there will be no phase separation, okay? So in other words, when you pour your methanol and your fuel in your tube and you shake it up, it's just going to look like one solid, it's just going to look clear like methanol. It's going to kind of have a yellow tinge to it. However, if it fails, what happens within that 5-minute settlement is you get di- and triglycerides that settle to the bottom in particulates. And this means that they did not get converted in the process, okay? So that means you may have to reprocess your batch to pull out those di- and triglycerides and make the batch over again. But that's going to cost you money because you're going to have more methanol and more sodium hydroxide, more heating time, and time to cook in the cooker for that process to happen. So you don't want this, you don't want your 27-3 test to fail. That means you've got to go back in your record and find out, well, what did I do wrong? Was my titration calculation wrong? Did I not use enough sodium hydroxide? Did I not use enough methanol? You know, you've got to adjust some of these factors. So that's why records are very important. So why would it fail? Well, like I said, you could have the titration incorrectly, not used enough catalyst to make the transesterification react, to break the glycerin, the fatty acids away from the glycerin backbone. Maybe you didn't heat or mix it enough. Or maybe you just didn't put enough methanol into your process. So that's why you keep good records, so that when this thing fails, or when any test that you run fails on it, you can kind of go back and look at your process and say, you know, where in my process did I do something wrong, okay? So after our 27-3 test, we're going to wash our fuel, and we wash our fuel because we want to remove the sodium hydroxide and the methanol from our fuel. Those are the corrosive components that will degrade your hoses in your trucks and tractors, your fuel systems, your injectors, and your pumps. So we want to wash, and we'll talk more extensively about this later. We want to wash our fuel. That seems odd that you want to put water in your fuel, but you have to wash it. What happens is the water has an affinity to attract the sodium ions in the batch operation here. So it just traps the sodium ions and they pull them to the bottom. So all the soap and the methanol can settle to the bottom. And then you drain it out and you wash it again. You drain it out and you wash it again. And you do that until your water's clear and you don't have any more soap in your fuel. Then you'll bubble dry it to remove the methanol, because methanol does evaporate. So you'll put some bubble stones in your fuel, you'll bubble it, the methanol will evaporate into the air. And then of course you want to drain again anything that's going to be at the bottom of your tank. And then we'll go through a BioClean filtration system, and that will remove the remaining ions of sodium and methanol from your system, and water of course too. So we're going to continue our video series and talk about all of these different things, and all the way down to a completed fuel system.